Hi, I'm George. Welcome to GMakes, and this is, I guess, technically part 2 of this kind of tutorial series. The first part was just a speed model of me, with some commentary of me modeling this wonderful gumball machine. The second one I modeled, I just wanted to redo the first one because I came up with some better techniques, like how to make this spiral in the middle there, which used geometry nodes and then convert it to geometry that I could then edit. Yeah, so that's basically that. If you want to check that out, please go ahead. It's, I think, a nice look in my process and just how I go about modeling things. It's just kind of a nice time. But in this tutorial, we are going to add some actual gumballs to this machine. As in, we're going to put some little spheres in here that are going to add some physics and kind of fill this thing out. It's not gonna be fully working. Like, you're not gonna be able to turn this little handle and have a gumball go through. That's just too much for this little tutorial. I might go further in depth on that, but at a minimum, we're gonna have a gumball or two come down this little spirally ramp and kind of disappear down to this bottom bit, even though there's no hole there. But we're gonna do that, and then maybe we'll have some at the top too that kind of fall and settle into place up here. So that's the gist of this. Mostly it's just a short kind of physics, hopefully short, should be short, physics tutorial focusing on this ball hitting these collision objects and everything, and then maybe getting some more at the top here. So let's get right to it. So first things first for physics is we're gonna want everything a lot bigger than I have it right here. So I'll save there real quick. Let me actually make sure I have my screencast keys turned on. Screencast keys turned on, so there we go. There we go, perfect. Right down here, you'll be able to see what I'm pressing. So let's get back to this gumball machine right here. If we go, it's not big. So if we just look at the body here, you can see it's about 6 meters tall. And even if I do a cube, so you can see it's decently large comparatively how big in real life. So this cube is 2 meters tall in the Blender scale. So you can see it is actually 6 meters tall. This is right here. This is an accurate measurement for the Z axis. So I might actually not scale this up right now. And if things get wonky, I might, but this is about not twice. This is about 6 times, because I guess a gumball machine is about 1 meter tall. So this gumball machine is about 6 times larger than it would be in real life. And that's scale. The larger the scale is really going to help with physics, getting any jittering, collision margins, and things like that. We want it to be actually fairly large. We don't necessarily need it to be life scale. So to start out, let's just go ahead and do it. We're going to have a UV sphere. This is going to be a gumball. I'm just going to write a head shade that's smooth. And I'm going to shrink it down. I'll go into looking straight on. And then we'll move this around. I'll move it up. Let's move it to the very top here. And we want something that looks like it's going to fit in our little ramp. And I might even take this and hide. Yes, so I just select that body and I just H just so that I can get focus on this. And I'm even just going to go into solid view. And you know what? Let me change up here some settings so I can stuff. So my matte cap, I'm going to change it to random. So that way I have different colors for everything. So I can kind of see the parts of my stuff differently. Also, I'll hide this as well. I think I have this as a collection. Coin box, yes. So if I guess that's not that. It's just not stuff not in coin box. I move this to coin box. Actually get everything. This is stuff that I should have done when I was modeling it. So that's my bad. Always make your collections labeled and model everything. You label your parts too. Ignore all my unlabeled parts. But there we go. So now we got this bit. So now we have this ball. Which I might as well label gumball. So now it actually is labeled. And if I hit play, if I hit spacebar, you can see down here on the timeline, nothing's happening. And that's because there's no physics. These are just objects. So let's get the basic physics going. If I go over here to this tab right here, which is labeled as physics properties, we just want a rigid body. And now if we hit play, it just falls, because there's nothing to collide with it. There's no collision, no other active rigid bodies going on. So we also select a spiral we want it to collide with, hit rigid body for that as well. But now if we hit play, they're both going to fall. And the reason for that is because they are both set to active, and they're not animated. We don't want it to be animated just because I don't want to mess with that. But again, if like your gumball for some reason is being iffy, you could also always go ahead and animate, tweak some things. But with the spiral selected, I'm going to go ahead and press passive. So that way, it's just going to stick there in the scene. It's still going to be collision, still be an active rigid body, or it's going to be a rigid body in the scene, but it's not going to, gravity's not going to affect it, things like that. It's just going to stay in place like an object, just have those collision properties. So now if I hit, I'm going to save. If I hit play, you can see, there we go. It's moving. It's a little iffy. We got to fine tune some things, but it's going. So a couple things that will help is if I control A and I apply scale to my gumball, make sure scale is applied to this thing as well. That helped a little bit already, you see. A couple other things are on this passive rigid body. So my spiral, I'm going to switch from convex hull to mesh and move this margin down. Let's start with 0.01 from the default. And you can see, there we go. That's pretty much already got it right away. There's a little hiccups here or there. But you can see, look we're getting a spiral. And the reason it's stopping is because my end right here is 250. And I'm going to keep that for now just so it's not super long. But you can see that's already good. I got the scale pretty much right on. It's kind of hidden, but you can see, if I can get in here, there's a bit of a gap between everything. So if I actually want to, I can go ahead and I can switch this from convex hull to, we might as well do sphere, because it is a sphere. And let's just see what that changed already. And that's giving it more of that rolling action. It's giving it let it speed up a bit. There we go. And that's actually pretty decent right away. And see, it was managed to get the end in 250 frames. And I'm going at 30 frames per second. Just kind of my standard, just because it's what most like digital platforms use. And I don't want to mess with 60 because then I have to render more frames. So I could also, if I didn't quite like that, I could add a collision margin and again put that like 0.01. Let's see what this does to it. Make sure I'm all the way back at the beginning. Boop. See, that just made it go a little faster. It's just adding speed up. I might as well keep it just because it will help be a little more physically accurate. And the last thing I want to do is kind of make this be a little more like an actual gumball. So I'm actually going to hide this bit as well and hide the dome. I'm just going to hide all that. Hide that. And then I'm going to take this ball, make sure I'm at number 1, otherwise it won't work. Because if you see, if I go to like 60 and then try to move it, it just snaps back because it's part of this, it's in the simulation. So, but if I take that at frame 1, move it up, let's say, excuse me, let's say there, that's a little tweaking. And now if I hit it, it has a little bit of jump, and then it goes down, and then it slowly builds up speed, yada, 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 all the way down, and whoop, there we go. Perfect. So now we have our gumball. That was pretty quick, right? Like physics, pretty straightforward. Again, if my scale was smaller, it might be funkier. If my scale was bigger, it might work better. But you know, the main things to look at for physics are making sure, all the way back to the beginning, making sure that for your collisions, that your shape matches your shape. So if you have a sphere, might as well use a sphere. But if you have something weird like this spiral, mesh is going to take a lot more time and effort on your computer's end, but it will help because we'll actually use the mesh of it to create all the collisions, as opposed to the default, which is convex hull, which just generally puts like a box. It kind of like cuts corners to get you the general shape, which is really great when you're doing a lot of objects and don't need very specific collisions. But when you're doing something like this, like some sort of ramp, you want that mesh, especially when you only have 2 physics objects right now. So there we go. So I like this little bit of physics. The thing that you can do when you like your physics is you can go ahead and you can go up here to the, where it's the world settings tab, not that one, this one. It is the scene properties tab rather. And you'll have rigid body world should be checked because you have a rigid body world in there. You can clear everything if you don't want it. You can rename the collection. You can add things to the collection. You can add any constraints you want. You can change the speed of it, make it faster or slower. If you've really scaled things up, You might want to double the speed or so, just so that gravity looks correct, but I think this is looking pretty good for my purposes. If you need more accuracy, you can add more substeps and solver iterations. So it's just how many times like it does math, essentially. Yeah, so a number of simulation steps taken per frame. So again, that will just slow down everything. 10's the default, 10's usually pretty good, but if things are getting wonky, especially if you have a lot of fast-moving objects, you might want to up one of those or both of them. Just experiment, just make sure you save a lot. But I'm going to go to cache, and I like this, and I want to keep it at 250 frames, and I'm just going to bake what I have. And since I've already played it through, it just baked what I have, and there we go. And now, like, I can move anything. So I could even move, go back to the front, and I can even move this spiral, and this ball is still going to have those physics because they're baked as an animation now, essentially. I can always clear that cache and go back and redo it or tweak something, but I have to clear that cache first. But that's also really helpful then if I didn't want this to be physics anymore and wanted to change it, or it was messing with my computer, I had other objects I wanted to be physics, I could really clear them. So we're going to bring back in a lot of those objects that we had. I can actually just, well, I can't do all that. Just got some other things hidden I don't want to mess with. But there we go. So now we have our gumball machine back. And if we go all the way to the beginning, you can see we have that drop out. And there we go. Gumball machine falls. Perfect. So let's add a little color to this now. So if we go here, and we're going to be in our shader editor, and we're going to add a new color, and we're going to call this gumball. Perfect. And then we're going to add a color to this. Gumballs are usually like, let's do, we have a lot of red, so let's do something like green. Let's make it like a green gumball. Perfect. There you go, green. We also want this to be fairly shiny, so the roughness will put down. And I like that. You could also do like a clear coat on it, since usually it's like the gum itself isn't shiny, but like there's like a sugar coating. So you could add a clear coat too. But I'm just going to do roughness of the actual sphere itself. Perfect. And you can see if I wanted a little more smoothness on this sphere, I could add a subdivision surface modifier to round out some of that bit. But I'm not going to be too up close to it, so I'm actually not going to do that. I'm going to keep it just in case I do end up zooming the camera in and I want to add that. But I'm not going to do that. So there we go. We have our gumball going down with some basic physics. And then it ends. Perfect. So let's do a big collection of gumballs up here. Okay, so physics for these gumballs. So right now we have this little physics guy going down. This might be a little distorted. I tried a lot of things. I thought I knew what I was doing, but then I tried a bunch of stuff. But then I'm just going back to my original idea, which is why there's a weird jump cut in it. That's what that was for, a little peek behind the scenes. But anyway, we have we have this gumball here, and I've duplicated it over here with no physics just to have an instance. We may not use that, but sadly, because I want to use physics for this top bit as well, we are actually going to get rid of this physics on here. Not get rid of the physics, but we're going to delete the cache because we're going to add a bunch of physics. But before we do that, just because I want to keep it a little bit longer, I'm going to go ahead and duplicate it again. All right, so now we got a gumball up here. But you can see it doesn't have any of that cached physics, though physics are a part of it. So I'm going to keep that just for now, because I'm going to add physics to them all later. So this will just make it easier. If I just go ahead and move this, and then I'm going to, this is a pretty standard method. I could also use geometry nodes, make a cube, but I don't want to open up that editor right now. So I'm just going to go to array, and we want count. I'm going to actually go, I guess I'll move this over along the x-axis. So then we go space these part a little bit, and we can also get rid of all the rotation on this, so it looks like it's rotated that way. So I can just delete that, just so it works a little bit better. Make sure that's solidly in there. Let me make that a little smaller. There we go. And it's being weird now because now this is all like part of it, part of the things. That's why the sphere is expanded. But don't worry about that. We're going to make this a little bigger, a couple more, and then we'll do another array modifier. But this one's not going to go along the x-axis. This was going to go along the y, positive y, lovely. Just to make a little like cube here, essentially, of these balls. And then we're going to add yet another array that's going to go along the z-axis negatively. And maybe we'll do 3 of those. I can get 4. I don't think I can get 4 without it getting weird. Yeah, so we'll do 3. And these are going to be the gumballs that are in our machine. So we're going to see how messy this gets right now. So first things first, I'm going to apply these array modifiers. But now I have this this is all one object right now. So if I go edit, it's all one object. That's not what I want. So with everything selected, I'm going to hit a right click in edit mode. Well, actually first I'm going to put these new collection and we'll name this gumballs because, so gumballs, have this selected and then edit mode and then right click. We're going to go to separate by loose parts. And there we go. So now these are all separate gumballs, but they're not, all the origins are kept in this one. So like if I rotate one, or if I move one, if I rotate one, you see it's rotating around the origin point there. That's not what we want. So if I go to, the reason I put these first in a group, the main one is just so that when they get separated, they're all in this group right here. So if I select objects, object, set origin to geometry, just because these are spheres, so they have the geometry, the mass, the surface area is all the same. There we go. And now we can see they all have the physics because the original one had physics. And they all aren't going to do anything because our physics are baked right now. So we're going to destroy this nice little ramp we have of this boy down there. And we're going to first scene properties tab and sadly delete our bake. Delete our wonderful bake. And now if I go ahead and hit play, nothing's happening again. So yeah, that's why. That had collision on it. So this, I have to have this rigid body. I'm going to make this a mesh. I'm also going to make this margin very, very small. As still want a little bit. Whoop. It needs to be passive, not active. Passive. And there we go. Gumballs. That was pretty straightforward. We got a bunch of gumballs. I can probably even add more if I wanted to. So again, if I select this bottom one and let's shift D it right there. We'll do the same thing. We'll do an array. Yeah, sweet. So there we go. And those are all going to be in our gumball ones again. There we go. Okay, so more gumballs. Tab A for selecting them all. Separate by loose parts. Tab back out, and then they're already selected, so I'm just going to set origin to geometry right there. Perfect. I'm going to save again, and now even more gumballs. Oh, yeah, perfect. And I think that's a good amount for now. I can always add more, doing this kind of same method. That seems to be working, and these collisions seem to be working pretty well. These are the same ones I had for the other gumball. So it's sphere, collision margin of 0.01. Didn't really change the friction. This one I made a collision margin really small, so that way I don't get anything too funky. But yeah, so that's working out pretty well. I'll keep it there for now. The final render might have a couple more gumballs, just because. Oh, the last thing I want to do is I want these to fall first before this guy. I want to give this a little time. Though it's not too bad. Like, again, I'm not simulating, but, you know, just in case of a full shot, I want these already to be positioned by this time this guy falls. So I am actually going to, he's been falling. I'll give him a full second. So I'm actually going to make him start. I'm gonna make him do I want deactivated or we can do animated? Let's try deactivated. I can animate that, right? Yeah, I can animate that. So he's gonna start deactivated. 30 seconds in, that will stop. Yeah, there we go, perfect. So that's just the deactivation. He starts deactivated. I just keyframed that deactivation. So he goes, and then 30 seconds in it stops. I might make that closer to 40. just to give this a little more time up here. They fall. Yeah, there we go. Perfect. So last thing is now this final texture. I want to not have all these be green. I love lime gumballs or the darker green watermelon ones, but I want these all to be different colors. And since this is real simple, since these are all separate objects, using the same texture, we can actually just do object info and then random. And you're going to see, I'm just going to Control C, copy that color real quick. They're going to give them all like black and white. Yeah, perfect. But now not quite what we want. We want colorful gumballs. So we're going to add a color ramp. And I'll make the white right now green. What colors are gumballs? We got, make these all like bright. I guess we got like the blue cyan ones, right? Cyan. And also I don't want, because these are gumballs, they're all one, excuse me, they're all very specific colors. So I'm going to change this to constant just so that we get the split. And then let me add another one. Let's make these the red ones. Perfect. And another one. We'll make these orange ones, right? Gumballs. Oh, and like I said, there's the dark green ones that are like here. But those are the watermelon ones. And then yeah, this will be the red because I got rid of that by accident. And there's usually like pink too, right? Are there pink gumballs? Maybe add some pink. I like pink, so we'll add some pink gumballs. Just a couple. We'll make that just a couple pink ones. Perfect. Maybe less cyan, maybe a little more baby blue. These. I don't know what flavor these would be. There we go. So now we have multicolored gumballs. And again, we can kind of mess with how many we want by changing the values down here on this color ramp. Maybe a couple more bright green ones. And you can see this one down here has changed to blue because it's just randomly selected. There we go. So now we got a basic physics, and I like this. So again, gumballs falling, and then a little bit later, our wonderful guy goes down the ramp. Is he going to make it all the way to the end now at 250 frames? No. So physics, the cache only has 250 frames in its memory. So if I go to 300, we're going to see if it will finish because it stopped either way because the cache, the physics stopped simulating at frame 250. And so it has 200 in its memory and it's going to go, and 300 is enough. Perfect. So I don't need to do this to 350. I can make this to 300. That saves me a couple frames. It looks like it does go through. So maybe I can even stop it like there. And that's what? That's frame 289. I could do 289. And then it's not going to go past that. 289 stops. Perfect. I'm good with that. That's all I need it for. Or maybe let's do one more frame so that way it again gets out of there. Yep, perfect. Okay, so there we go. We got a gumball. We got a gumball machine. And we got physics that we like. Perfect. So now I'm just going to, again, what I did before, save, and then hit. I'm actually going to do current cache to bake because I like the current cache. And I don't need to rebake it since it's already been playing through perfectly. And then we can see, if I go into render view, all these wonderful little gumballs. I could go through and be even like more specific with all of this. Like sometimes gumballs aren't perfect, so maybe I want to do some Musgrave texture. And then a bump. Oop, bump, actually use that bump. Normal, height into height. And that's way too strong. As you can see, no gumball looks quite like that. But if I just add a little bit of wibbly wobbliness, it will kind of give that candy coating look to it. I could do something similar on this glass as well. I could do a Musgrave texture there because glass often has a Musgrave. Oh, I already just got so a bump. But of course, we're not using this. We're using this up here. And I've messed around with that color, but let's do height. And then if we put this normal into this glass BSDF, you can see it does funky stuff. I want the scale a little bit bigger, or bigger, so I go small. You gotta, it starts to kind of mess sometimes with the actual like subdivision, so you can't go too much. But again, I just want a little bit. Just a little bit of wibbliness in there. You can do that with everything. I can also add, you could also add like kids' handprints onto this glass, stuff like that. But I'll leave it at there right now because I've already been droning on a bit about all these fun physics and modeling. I just like this gumball machine. So that's where I'm going to leave it. I'll play those physics back one more time and then I'll sign out. So we got physics. But that's it. That's been this kind of physics tutorial. Hopefully this is helpful. Hopefully if you've been modeling along or modeled your own gumball machine, or we're trying to figure out how to get some basic physics to work, hopefully this helped. It was kind of more of a talk through than a straight up tutorial. If you want to see this gumball machine being modeled, check out my speed model I did of my gumball machine version 2, because I have an older one, but I like this one more. And I also talk through my process in this video for modeling this current gumball machine. Yeah, if you have any questions or comments or things you'd like to see me try, or you want a more straightforward, just basics physics tutorial, like using cubes or using a basic sphere or something that's not also kind of a modeling and process video, feel free to let me know because I'm happy to do that. And yeah, I'll catch you next time. Peace.